Poultry meat and eggs provide nutritionally beneficial food containing protein of high quality. This is accompanied by low levels of fat which have a favorable mix of fatty acids. Chicken meat contains about 2 to 3 times as much polyunsaturated fat as most types of red meat when measured by weight. However, for boneless, skinless chicken breast, the amount is much lower. A 100 grams serving of baked chicken breast contains 4 grams of fat and 31 grams of protein, compared to 10 grams of fat and 27 grams of protein for the same portion of broiled, lean skirt steak. A 2011 study by the Translational Genomics Research Institute showed that 47% of the meat and poultry sold in United States grocery stores was contaminated with Staphylococcus aureus, and 52% of the bacteria concerned showed resistance to at least 3 groups of antibiotics. Thorough cooking of the product would kill these bacteria, but a risk of cross-contamination from improper handling of the raw product is still present. Also, some risk is present for consumers of poultry meat and eggs to bacterial infections such as Salmonella and Campylobacter. Poultry products may become contaminated by these bacteria during handling, processing, marketing, or storage, resulting in foodborne illness if the product is improperly cooked or handled. In general, avian influenza is a disease of birds caused by bird-specific influenza A virus that is not normally transferred to people. However, people in contact with live poultry are at the greatest risk of becoming infected with the virus, and this is of particular concern in areas such as Southeast Asia, where the disease is endemic in the wild bird population and domestic poultry can become infected. The virus possibly could mutate to become highly virulent and infectious in humans and cause an influenza pandemic. Bacteria can be grown in the laboratory on nutrient culture media, but viruses need living cells in which to replicate. Many vaccines to infectious diseases can be grown in fertilized chicken eggs. Millions of eggs are used each year to generate the annual flu vaccine requirements, a complex process that takes about 6 months after the decision is made as to what strains of virus to include in the new vaccine. A problem with using eggs for this purpose is that people with egg allergies are unable to be immunized, but this disadvantage may be overcome as new techniques for cell-based rather than egg-based culture become available. Cell-based culture will also be useful in a pandemic when it may be difficult to acquire a sufficiently large quantity of suitable sterile, fertile eggs.